Hello guys, welcome to neural network practice session. So in this session we are going to apply neural network to build an image classifier. In this practice we are using MNIST dataset, and for your information, MNIST is a collection of handwritten digits from 0 until 9. So that would mean in total we are having 10 classes. So we start by importing all the necessary packages. And as you can see, I'm using thoughtvision.dataset.mnist to download the dataset. And you could specify whether you want to download train or test dataset. So in this case, I download both train and test dataset. I am going to use train dataset to train our neural network model and later on test its performance on the test dataset here. So instead of loading all the image into the memory at the same time, I'm going to load a batch of 128 image into the memory. So therefore I need to specify batch size equal to 128 here. And to achieve that, I need to create one data loader for the training set and one data loader for the test set here. So if you are running this notebook for the first time, it's gonna take a bit of time to download all the images from the server. And since I have run this notebook before, then it won't re-download the images again. Now let's examine one of the images. So here is an example image of digit 0. As you can see, each image is basically a 2D tensor of 28 by 28. So we are going to implement very simple neural network architecture. We have one input layer, one hidden layer, and one output layer. So in Python, we could check whether we have GPU or not. And in this case, we are going to use GPU if we have, otherwise we would use CPU instead. So here are some hyperparameters for the network architecture. We are going to use input size of 784 because our input image is a tensor of 28 by 28. And in the hidden layer, we are going to use 500 neurons. And lastly, in the output layer, we're going to use 10 neurons since our number of class is 10. And we are going to train our neural network for 5 epochs, and we apply learning rate of 0.001. One way to create neural network is to extend from the base class nn.module, and this is exactly what we are doing in this practice here. So we extend the class nn.module here, and then inside our derived class we are going to have two connections. So one connection we call FC1 is basically the connection from input to the hidden layer, and later on we're gonna have the connection from hidden layer to the output layer. And then we are going to apply ReLU activation function. And in the forward method is exactly what the forward run in our neural network. So our neural network would take input X and feed it to FC1, and later on apply activation function, which is ReLU on the result of FC1, and later on feed these outputs to the FC2, and the final output would be the result from FC2. Now let's create a neural network object from our derived class here. So we need to pass the input argument, which include the input size, hidden size, and finally the number of class. And after we create the neural network object, we could send it to device. So if we run on CPU, we would send this object to CPU. And so after define the network architecture, we need to define the loss function and optimizer. So in this case, I'm going to use cross entropy loss because it is a multi-class classification problem. And for the optimizer, I'm going to use Adam optimizer. And we need to supply the learning rate which we have defined earlier. After we define network architect, loss function, and optimizer, we are ready to implement the training loop. And for the training loop, we need to loop over the epoch. And for each epoch, we need to load different batch of image from the train loader. So every time we load, we need to load a batch of images and their corresponding label. And we need to pass our images to our neural network, which would produce the output. And after that, we calculate the loss value by comparing the output from the neural network and the actual label of the images. After we calculate the loss, we need to call loss.backward to calculate the gradient of the network. And after that, we can update the parameter of the network by calling optimizer.step. So please pay attention to please pay attention to optimizer.zero gradient here. It is the step that we need to remove all the previously accumulated gradient if there is any in our network. So we just need to repeat this loop until the last epoch here. So if you are executing this cell of code, you should be able to see similar output here. So as you can see, the loss value decreased from the value of 0.38 all the way until 0.06. So that would mean our training implement is doing the right thing. So now we are ready to test our trained neural network on the test dataset. And the way we do that is very similar to our training loop. We need to load different batch of image from test loader here. And then for every batch, we need to pass the image to our trained neural network, which would produce the output. And later on, we compare the output by neural network to the actual label. And then we keep track of the number of images that our network correctly predicts. And finally, we would calculate the overall accuracy of the network on the test set. So if you executing this cell of code here, you would see that we have achieved the accuracy of 97.89. So that is not too bad. Okay, that is all for our training on the that is all for our practice on the neural network. Thank you very much.